drawing Lewis structures, more specifically drawing Lewis structures for compounds containing second row elements and hydrogen. And to do so, we can do so by following the 3 easy steps laid out here for us on the right side of our slide here. Let's take a look at them and then we'll do a few examples. Step 1, calculate the total number of valence electrons in the molecule or ion. And in step 2, we're going to need to determine the central atom of the molecule or ion, and that's usually the least electronegative atom. And if you recall, we covered electronegativity extensively in the periodic table lecture series. Thus, should you require further information on electronegativity, you can watch that lecture at any time. Now, in step 3, we're going to go ahead and just draw the diagram for the molecule or ion. And there's a few points that we should take note of. Firstly here, as it says, a hydrogen atom always forms one bond, and hydrogen is always a terminal atom in a Lewis diagram. Secondly, sum of all bonding electrons and unshared pairs for atoms in the second row of the periodic table is never greater than 8. However, atoms may have fewer than 8 electrons, as we had seen with boron. All right, let's follow our steps and do a few examples here of for drawing Lewis structures. And we'll begin here with the H2O molecule, water molecule. Now, if we recall, we had previously stated that a representative atom or we can say a main group, a representative or main group element has the same number of valence electrons as its group number, right? Therefore, each of these hydrogen atoms should have 1 valence electron, as hydrogen is a main group 1 element, and oxygen, being a main group 6 element, should have 6 valence electrons. And as you see here, we have a total of 8 valence electrons, right? 1 for each hydrogen and 6 for the oxygen as such. Now, next, so that was for step 1. So for step 2, we're going to need to determine the central atom of the molecule or ion, and it's usually the least electronegative atom. However, for our example, we also stated down here that hydrogen is always a terminal atom in a Lewis diagram, right? So we know that the oxygen is going to be the central atom in this example. And the valence electrons, as we see here, they're always organized into electron pairs as such. And the hydrogen, well, we know that the hydrogen always forms one bond, right? But besides the hydrogen, we're going to set up the octet configuration for the oxygen, as we see here. And the oxygen forms 2 bonds, right? One here and one here to get that octet configuration. Now, once we've satisfied steps 1, 2, 3, and we have that octet configuration for our necessary atoms, then we can go ahead and replace the shared electrons between 2 atoms, that being, for example, between the oxygen and the hydrogen here, with a single straight line for the covalent bond as such. And the resultant Lewis structure for a water molecule is as follows. Now next, let's do the Lewis structure for a carbon dioxide molecule here. We know that carbon is a main group 4 element. It's going to have 4 valence electrons. Each oxygen atom is going to have 6 valence electrons for a total of 16 valence electrons, as you see here. Now, although the answer is given here, if the answer was not given here, how can we determine whether oxygen or carbon is the central atom? Remember, it's the one that has the least the central atom is the one that's the least electronegative atom. And if you recall, this slide here is from our periodic table lecture series when we talked about electronegativity. We stated that electronegativity increases going up a group and it increases going across a row on the periodic table. And now if we take a look, we see that we have carbon right here and we have oxygen right here, and we see that oxygen is going to be more electronegative. Therefore, carbon is going to be the central atom. Okay, now if we go back one slide here, we see that is why carbon is our central atom. Now, to obtain that octet configuration, right, the carbon here is going to need to form 4 bonds, right, while the oxygen, it forms 2 bonds, resulting in 2 double bonds between the oxygen and carbon here, and the carbon and the oxygen here as well. And the final structure for the carbon dioxide molecule is as follows. Now, next for hydrogen cyanide, we know that hydrogen has 1 valence electron, We know that the carbon has 4 valence electrons, and we know that nitrogen has 5 valence electrons for a total of, it doesn't say here, but this should be a total of 10 valence electrons as such. Now, let's go ahead and determine in step 2, right? We need to determine the central atom, and as it says here, it's usually the least electronegative atom. So we see here that carbon and nitrogen, with their positions on the periodic table, we see that carbon is to the left, and it's going to be, it's not as electronegative as nitrogen, thus carbon is going to be our central atom. So if we come back here, now we see that carbon is our central atom. Now we know that the hydrogen is just going to, hydrogen always forms one bond, right? Thus, the hydrogen is going to form that one bond with the carbon, as we see here. Now, in order to achieve that octet configuration, the carbon and the nitrogen are going to need to form 3 bonds, as we see here, which is going to result in a triple bond between the carbon and the nitrogen, and the resulting Lewis structure for the hydrogen cyanide is as follows. Okay, let's proceed now to our next slide here.